Next up on the podium will be Jonny Martin and Tim Hoffman, who used to work together at a small carrier in New Zealand, talking about how to build a network on a shoestring. They'll both talk. Jonny will start first, and at about slide 16 or 17, Tim will pick up from there and finish it off. All right, thank you very much.
Alrighty, thanks. So I'm Jonny Martin. As just noted, we worked together at a company called FX Networks in New Zealand. We had a short period of overlap, and then Tim continued working there while I moved on. So we're going to split the talk up approximately along those lines. A little bit of background here. The company was founded by a man called Roger DeSalis. He was tired of the over-engineered and overpriced options that we had in the market in New Zealand at the time, and the way it was holding back the country and its competitiveness. And in terms of pricing, this is back in the days when transit was on the order of $1,000 a meg, so expensive. So we wanted to change price and performance by at least an order of magnitude, and thankfully we did that and more. The funding came from a family friend of Roger's who found civil works far more interesting than the network, and things were funded as such. So this is a man who used to take advice from his dogs when it came to investment decisions, and he also enjoyed going out RVing with the contracting crews laying the cable and actually watching the fibre go on the ground. So back in 2005, there were two companies in New Zealand that really had intercity fibre. They didn't really lease to others. It was very difficult to get anything approximating level 1 or layer 1 or wave or layer 2 capacity through the country. If you could get it, it was mighty expensive. So over a period of 5 or 6 years, we laid thousands of kilometres of fibre around the country, and we built a nationwide network with on the order of 50 POPs. We often started these fibre builds with only about a quarter of the funding that we needed. So that made for interesting times for us trying to build the network and those that were ultimately having to pay the bills. So here's how it's done. Not the best way of doing it, but timing often meant that fibre would get laid across easements through farmland. Luckily, the sheep weren't too brutal. The fibre went just fine. So obviously, things like this would be a calculated risk if customer retention and customer income was reliant on getting new infrastructure up. We'd go and do what we had to do. So in this case, it's line in the field. Other cases, it would be cable tied or zip tied along the fence line down the bottom. So here's some of the stories from pulling this off, and some of the things we learnt, and I feel have really helped us in our careers over time in terms of understanding and being able to make some of the correct trade-offs when you've got multiple options. Big disclaimer here that probably should have been bigger on the slide. FX was acquired back in 2014, and the network's been refreshed. The network that's there now, which is owned by what I think must be the third largest carrier in Australasia now, is completely different. So don't be reading into this and thinking that's what you're buying if you're buying from them now. So back then we didn't have a lot of money to spend. All right, so we were in a country of less than 5 million people, and it's about 2/3 the size of California. So it's a very low population density, very large distances, inhospitable terrain that we had to cover. We didn't have a lot of staff to do all this, and we didn't really have resident engineers or vendors falling over us to help us make this work. And the last 2 points there, we didn't have a lot of time or revenue at the start, and they were kind of related because sales guys and sales ladies, they'll often promise something to a customer. Sure, we'll put 500 kilometres of fibre in to join these two cities. Sign the contract. Get the initial revenue and leave it up to the engineers to fix it, put the thing in. So we couldn't have got the business off the ground with an ideal network at the start. We didn't have the time or resources for it, so we had to be very creative. And really the only way you can make something like this work is when everyone involved has a deep knowledge about everything in the network. So by that I mean our systems person. He also knew a lot about, or learnt a lot about WDM technologies, the physical running of fibre, the mechanics of fibre trays and splices and so on. Our power person got learned a lot more about the network and in-depth knowledge there. The crews that were actually laying fibre started to learn more about higher up the stack, and this happened right across the small company. And in fact, I think at one point we had virtually 100% of the country had been out, 100% of the company had been out to visit a POP or do work at some point in time. Right? So whether that's a road trip up the country delivering UPSs or installing chassis switches or just visiting local POPs to assist when that's required. So I'm going to talk first a little bit about what we call our transmission network. Now, up the top right there, let's see if we go there. There's a little APCON unit in Telepatch. Now, this is really not designed for what we used it for, though it turned out to work great. It's really designed for soft patching of different media types. In our case, all we cared about was 10 gig with ZR optics. So that gets us 80 kilometers. Founder jumps in a car, starts driving, stops around about the 70 kilometer mark, and starts looking for somewhere to put a POP. That's literally how it happened. One of the great pieces about this, the founder was pretty impressed when his car busted after 500,000 kilometers. So we'd house in these POPs an APCON or a layer 2 switch at these sites, and it was just Ethernet segment after Ethernet segment after Ethernet segment. A very cheap and effective way to start out a network, bearing in mind you're doing this without the luxury of time and money at that point in time. The bottom two photos that we have here are, let me go there. This is in a railway control hut in the Kapiti Coast, on the bottom of the North Island. So on the right there we see we've got the filing cabinet mounting method, which revolves around stacking neatly your equipment on top of the filing cabinet. Over time that moved to something approximating more of a normal install. We've got a rack, which came from, I think it came from an auction somewhere. Trailers of racks would turn up from time to time, and you give them the instruction that these are the racks to use, go make it happen. So there we've upgraded to a bigger switch, a lot more UPS, since this was a site where we didn't control the generator, we'd have to compensate with UPS. One of the interesting things about the fibre here is the day before the railway company in New Zealand was privatised, our illustrious founder managed to sign a deal and get access to 2 pairs of fibre along a couple of spans, which the railway company had written off as useless because they couldn't work out how to use it, and easement rights throughout the rest of the network. So that was very, very, very lucky timing, since the day after that, I'm sure the privatised company would have realised that there was some value in the assets that were just signed up. Part of that was we had to migrate off of one of the fibre pairs a 2 meg E1 circuit, which was being used for train control. So luckily, we worked out how to do that TDM stuff over IP. We gave them a replacement E1 circuit and got that up and running. Skip that one for a minute. So here's what the transmission network looks like. We've got the north of the country on the left and the south of the country on the right. This is actually a collapsed ring. So day one, we had a single fibre path. So everything here is hitting the same pops, the exact same path, and the exact same cable. So we had to be very careful when you're trying to build redundancy with a single cable. It comes down to thinking about things like which tube in a fibre optic cable are you going to pick a fibre out of. And we'd end up using 3 tubes. One tube would pull out a pair of fibres for what we called our core, another pair from the next tube, which was as opposite and the cable that we could get it for our access side, and then another tube and another pair out of that for our management network, which we'll get onto a little bit later. And then we had a small number of PEs smattered around the network, which gave us the ability to bridge traffic between the sides and keep things running as best we could in the event of power or equipment failures. Obviously, if we get a fibre cut, there's not much we could do about that. The DWDM spans, we can see 2 of them, small ones there. They were just point-to-point metro kit, so Cisco ONS from back in the day, around about 150 kilometres, which was right on the limits of what the gear could really do on the fibre we had without amplifiers in the middle. Took a little bit of finagling, but we were able to get it working. And then through the middle up here, you can see we've got our point-to-point pieces with these APCON layer 1 repeaters. On our access side, this was a chain of Ethernet switches all the way up. I think we got up to 11 hops over Ethernet, but again, it gets you the 10 gig channels. You can start working, you can start selling service, and then you can improve over time as resources become available. Through the building of this network, optical knowledge and optical testing became very important. So we had minimal optical test equipment at the start. It's crazy to think that we had a fibre company that didn't own an OTDR, right? You know, it's just not something you do this in this day and age, but that's where we were. So we had to engage contractors to do the testing when it was critical, and we personally carried around a Cisco 6500 with DOM optics as our piece of test gear. Not the easiest thing to carry around, but again, gets the job done, and that was the most important thing. So that also allowed us to measure our transmit power, measure the receive power at the far end, and test the amount of headroom we had and performance of our optical links. One of our 80 kilometre spans turned out to eventually be 93 kilometres, which made us all a bit nervous, since the only backup plan for fixing this would be to drop a new pop in the middle of that span, which we simply didn't have the time for, even if we had the money. So, I mean, the story of this one is typical of most companies. We get told, you've got an 83 kilometre span coming, is that going to be okay? Well, yeah, we can probably make do with that. Well, I drove a bit more accurately, it turned out to be 85 kilometres. Is that going to work? Well, that's getting hard, we'll see what we can do. They lay the fibre, they shoot the OTDR, they tell us, oh, actually it's 90 kilometres. Whoa, this is a problem. Even more of a problem was the same contractors that laid the fibre, later that day, they cut the fibre and they were shooting an incomplete fibre span. So it turned out to be 93 kilometres. So thankfully for this, with this particular span, we didn't run into any issues with dispersion or anything on the link. So with straight up 10 gig ZR optics on new fibre, that worked fine. One of the important things we needed to do on this span though was work out exactly what headroom we had with our optics. So it was really important to grade the optics. We graded them, took the most powerful transmitters and measured the receive sensitivity, which is as simple as introducing attenuation into the link and measuring the performance at IP over that link to see when it drops down. So this allowed us to get the best optics to put into production, and just as important, get the next best optics to include on site as spares, since we couldn't just put any optics into that link. And down the bottom right there, we can see this is a technique known as the mandrel wrap or the mandrel bend technique. You take a chapstick and you wind your fibre around it, and it introduces relatively controlled attenuation into your fibre. So we're using a duplex fibre and a light source and power meter on one side, device under test on the other. You could wrap it very carefully until the point in time at which you start losing packets, and that gives you an indication of how much headroom you've got. So many stories like this as we went through, which helped us to really understand the network. Everybody involved in the company got to learn some of these things, and it proved to be very useful as we were building the network. Power is a pretty important thing in any network. So we came to the eventual conclusion that we'd run with 1,500 and 3,000 VA commodity UPSs or stacks of them to actually protect the network. And the reason we made this choice is because it allowed non-electricians to work on the network, to upgrade it, to change things out. And one of the people on the team was a licensed electrician, which really helped us, a guy called Lindsay Druid, which meant he could design power systems for us, but more importantly, he could install them neatly, he could label things properly and document them so anybody can understand what's happening with the power. One of the big keys here was from day one, we made the decision to stick everything behind a transfer switch. So these were high quality manual transfer switches, right? It's basically just a big switch that switches one power source to another and does it within a 50 hertz cycle. So most equipment will be perfectly happy with that and continue running. So that allowed us to upgrade things over time, move things about without disrupting the network. We were able to store up to 500 litres of diesel at any location in New Zealand without licensing, which turned out to be really helpful given how dodgy the power could be in parts of New Zealand. And we came to rely on that in a few cases. Our co-location facilities, I wouldn't really call co-location. We coined the term bro-location. These included such gems as the vault of an old bank that a cafe didn't have a use for, concrete bunkers that we just dropped on the side of the road and hooked up, railway control huts, train stations, the top of buildings, pretty much anywhere where we could get an environment that we could make work for us, and within 80 kilometres of the next nearest pole. Would pay people for space, land, easements, whatever we needed with 100 meg internet connections. In some cases, complete farming communities would actually build a mini network for them to give them internet connectivity, and that greatly eases the ability to actually run our fibre. We also made the decision in a lot of cases to run with air vents rather than air conditioning. A lot of this gear is just transmission gear. And even in the bigger pops, we weren't hosting servers. We were trying our hardest to have our sales team not sell hosting to others. So it didn't get too hot in these pops, and passive air cooling or forced air cooling in a lot of cases was all that was required. So that helps a lot with power. So you can actually design a power system that's robust and switches to a low-cost generator pretty cheap. The way we chose to do it was with what a lot of you probably know as a terminal server, SNMP server or some such, with loads of dry contacts, analog inputs, analog outputs and so forth to allow us to monitor everything, to actuate relays and such, to test generators, for example. And not only just test the generators, but we could also create an actual power cut on the incoming mains and test that things work exactly as they should, so a live failure test. And that's something that saw us pretty good. Over time, we got to the point where at least once a month we were cutting power to a pop to be able to test that it works. And we found that to be far more valuable than having a more advanced power system, but one that you learn to rely on and never actually understand the intricacies of or know what's going to happen if you have a power failure. Right? And I think it was BT, not BT,
British Airways.
BA, British Airways found this out in quite spectacular fashion recently. Another thing we chose to not do at the start was not buy redundant power supply units due to cost. So again, this is where having transfer switches was incredibly important because it meant we could, again, service UPSs and do work in the future without having to interrupt power. Eventually we got to the point where we did have redundancy, but not at start. For some of the smaller kit which had dual power supplies or you could do relatively cost effectively, we would use those, and that allowed us to avoid the transfer switch as a point of failure. So we could have switching from generator to UPS and rely on the fact that we've got two power supplies in the equipment to keep things going. So down the left here is a stack of some event sensors. I think essentially a site boss, I think, was the equipment we were using. This is, in fact, one half of a power board. So we'd have a main side, which had all the mains there, and then a second side, which is the low voltage side, and that would have all our relays for sensing and actuation, all the incoming environmental monitors. And from the start, we had really good monitoring, but a few years later, we had, once we'd learnt from some of the things we'd done in the past, we were at the point where we could monitor and control everything within a pop, all relatively cheaply. It's kind of like a poor man's ladder logic PLC type thing, except it's all scripting and SNMP boxes. So our bro location, we never really had problems with heat or aircon. We were able to control fans if we needed to proactively to cool things down, or just rely on a local loop that's looking at temperature and actuating them as required. One thing we did find, it's dangerous for higher up management to have master pop keys. So that kind of hastened the shift to an electronic control system. But the last thing you want in the middle of the night when you've got customers complaining is a founder driving around the countryside having a go at fixing it. So master pop keys, while it was necessary at start, we got rid of them pretty quick. Here's an example of another POP in the Wellington railway station. It's a back room in the railway station of a capital city. It's an earthquake-prone zone, so they required ISO bases or isolating bases for the racks to separate the racks and their movement from that of the actual building structure. We couldn't get any locally, and to import them would cost quite a bit and take a lot of time. So we ended up relying on some custom heavy steel plates that we had fabricated, rolling on bearings with what was essentially elastic bands holding it together. And this is another example where some of the folks on our contracting teams and the outside plant people were able to help us with that sort of design. Another site where we had unreliable power, and unreliable in the sense that we were given power, we didn't control the generator, all we saw was the power coming into the rack. So we had to compensate with a lot of battery, a lot of monitoring, and detailed knowledge of the power draw. So we got into the habit of analysing the power drain of every piece of equipment we had, working out how long we could support a POP on new batteries, and derate it for what we'd expect of batteries that have been in use for some time. And at this point, we had a single PE feeding our primary 911 call centre. Not our choice, we were the backup provider for them, but when your backup link is 10 times faster and more reliable than your primary link, you run with your backup. And at one point in time, Tim and a colleague physically moved a PE 12U up in a rack without dropping a single packet or a single router, which was quite impressive. One of our best sites for power happened to be right here inside a hydro dam. So this was, I think this was probably the biggest generator we had on the network supporting the site. We had to get electrical certifications to get entry to here to actually service things. So there's a group of us up the top there after getting our green ticket, doing our switchyard and generator room training, learning how to ground a vehicle without clipping to a plastic bumper and all that sort of good stuff. Downside of this though is it's pretty hard to get to and get into fast if you have equipment failure. So again, just comes down to planning in advance and knowing if you have a failure, you've got to react quickly, you've got very small decision times. Here we never had a single problem with power, and we were so happy with it and with talking with the crews there that we didn't even bother with UPSs in the first instance. We deemed them just to be more of a failure point than providing any sort of protection. So here's we're having dual power supplies in a unit, does fine, right, with AB power. And C if you include the generator they got. Another one, the bank vault. So it's a cafe, bought a bank, didn't know what to do with the bank vault. It was in the right place for us, so we put a POP there. One of our favourites for POPs was the use of what we called the standard concrete bunker. So these were prefabricated buildings, which didn't take too long to build, and we could stick them on a truck, turn up to a site, drop them in, hook them up to utility power and the incoming and outgoing fibres, and away we go. One of these got dropped prior to obtaining formal permission. Unfortunately, it happened to be on New Zealand Army land. They're not terribly forgiving about this sort of thing. It was actually not far from one of the training ranges they have in Wairau. And we got through that one by exhausting some personal relationships and smoothing things over with some people we knew in the Defence Force. Not exactly recommended, but again, as engineers, we just have to deal with what we're handed. So in here we can see about 20% of the bunker is a generator, walled-off generator space. Plenty of ventilation, roller door coming down, locking it all up. The gas tank, the generator is all in there together, and then the rest of the room is there. Enough room for about 5 or 6 racks. Nothing high power draw or generating too much heat. This is one we chose to put an air conditioning unit on at the start. It gets pretty hot in summer, and we deem that necessary. And one of the other interesting POPs we had was up in the Sky Tower, which is the tallest structure in New Zealand, around about 330 metres high. It was previously the de facto interconnection point in New Zealand. Primary peering point, the Auckland Peering Exchange was there, and just about all transit to the world passed through those black bands up the top of the tower, so up on the 48th and up the 65th floor there. I blame Joe Abley for this. It's a terrible place for having a meet me room, but it did have a single bonus, which was the ability to run your own cross connects. So you didn't have to pay, you didn't have to ask anyone, you just jumped up a ladder, dropped your cable in your rack, went to another one, dropped it down there, plugged things in, and everyone was happy until it came time to kind of trace things out and work out what was going on. But the power there was pretty unreliable, and if you wanted to run cables between floors, that's when you need a licensed contractor because you have to jump in the core of the tower and run the cable without making it to the bottom. The gear could reach up to 50 degrees Celsius in summer, so pretty hot. I mean, it's fine for wireless folks because they get a great wireless shot to virtually the entire Auckland region. And a lot of ISPs, we used to look at the seasons by looking at the temperature of their equipment. You could actually see the quadernal cycle, I guess, of temperature throughout the year. So as a result of this, we kept minimal edge equipment here, since it wasn't a terribly great place to put all this, but it was required since there were so many people that wanted to connect in a place like that. So at this point, I'll hand over to Tim, who's going to continue on the story and some of the things we learned.
Thank you. So the probably most notable pop we had was a bunker on the roof of a television station in Christchurch. This was pretty ideal because we partnered with a radio shot company who could get good tails anywhere around the city. But it was challenging because you had to kind of walk up onto the roof, and in the winter it could be a bit icy. And there was kind of a generator up there and our pop and a number of other pops. This is one of those ones we didn't control the UPS or the generators. So when the Christchurch earthquake happened and the building almost fell down, no one actually knew how long we had on the generator before the pop would fail. So the pop actually survived even though the building was in pieces. And the fibre was all working, but we were just kind of unsure as to how much time there was to migrate services out. So it was kind of a mad rush to move it to the other pop we'd built in Christchurch. And actually after the earthquake, and after their building had been knocked down, they actually borrowed our office to do broadcasts from, which is a little bit further out in Christchurch. It was pretty fun. And onto the fibre, we actually learned a lot about building fibre over time. And Daniel Griggs did a great presentation on how we did this at PACNOT 7, and there's a link there. But essentially we started by using diggers and mold plows, but we kind of linearly just laid fibre straight into the ground. And the challenge was if you ran into something you couldn't get past, you couldn't just move on. You had to stop there and wait, say, a couple of hours for a different piece of heavy equipment to come so you could plow through it or drill through it. So we moved over time to using conduit, and then we'd blow the fibre through. And that meant we could kind of run along with a digger or a plough and get all the easy parts, then come along later with other parts and attach them all together. And there's some quite cool equipment photos that are nerdy and awesome. But one of the biggest challenges was fleeting the fibre. So that's when you've got to untwist it as it comes off the coil. And initially we actually did this by hand. And then over time we moved to having our own fleeting machine that we got built. And that made things a lot faster. But a few kind of war stories from this is that at one point some of our contractors put a directional drill through a lamppost. And then the council decided that they wanted to age out and remove the lamppost. And in fact, discovered that our fibre was punched through a hole in the middle of it. So we got this kind of irate call from the council where they politely asked us to remove our fibre from inside their lamppost. Another one that was interesting is we found it was really important to mark your fibre. So another provider, Telstra, was very bad at this, and there was a 300-kilometre section they didn't know where it was. So we kept getting their contractors out to point out where the fibre was, so we didn't drill into it, and we caused maybe 5 or 6 cuts on it, and got to the point where they were saying, if you cut it again, we might actually not be able to use this due to the loss. So we took great care on our fibre to make sure that we had very clear markings and posts, and also we actually laid a plastic ribbon about 20 centimetres under the ground, where the fibre was 1 metre under the ground, so that people would strike that first and see the warning sign. And the other cool thing we did is that we actually, beside the fibre, we had a piece of copper wire. So an OTDR is pretty good at telling you within a few hundred metres where your fault is, but you can use the copper wire, which we popped up at every 100 metres or so into a pole, to actually pinpoint exactly where the fault was, because you could tell where it was cut. And then if you can get within 100 metres, you can generally see whether there's a digger or something digging up your fibre. And probably the other fun thing was when someone built a road over our fibre, because they didn't check. So we kind of had this fibre fault, and we got there, and there was this big construction thing, and we realised that actually managed to successfully seal over our metre depth buried fibre with a road for half a kilometre before they actually broke our fibre. It's pretty impressive. And finally, the other great fibre war story was that we always ran into problems with rats, because rats like the gel inside of the fibre. So what was really interesting is by selecting tubes on either side of the fibre, often we would survive fibre cuts because the rats would only chew in far enough to get into the gel before they got tired of it. So we really tried to make sure we buried it well and had metal sheaths across the bridge. But at the same time, we had to be very, it was very good having those two tubes, so we were less at risk from that. So the original network was actually built with just 5 PEs, and we chose Cisco 7600s and then 6500s as switches because at the time you could run the 7600 software unlicensed and unsupported on the 7600 software on a 6500, so we could get cheaper spares. And over time, this expanded to about 40 or 50 PEs. But what we'd actually do initially is just long line customers from a switch to 2 different PEs in 2 different directions and provide them 2 services. So if one failed, they could kind of fail over, and that made it a lot cheaper. And the key here was actually really understanding how the network would fail. So we didn't run spanning tree, we ran everything loop free, and the MPLS call links were another VLAN on the transmission network. But while that would fail at times, we knew how it would fail, so we could plan for that and provide services around that. And again, it was pretty simple because the main business was layer 2 wholesale. So we decided not to buy cards that could do shaping. So we figured if someone bought a 500 meg service, if we just gave them a 1 gig service, it's actually cheaper than going and figuring out how to get a card that would work to do shaping to kind of a fine grained level. And as part of that, we ran really old versions of code and a very small number of features. So as we know, the more features you have, the more bugs you have. And we never really upgraded because of that. So it was a really stable, simple, dumb network. And we, over time, bought a transit provider. And what we decided to do is actually keep that separate from the main network. We just had stacks and stacks of 7201s, which were buying layer 2 services off the network. And you could scale them pretty wide by having lots of different things plugged into lots of routers and just making sure you spread the customers out enough. So everything we were doing was trying to make it cheap. But it was actually pretty easy to build a pretty good network with cheap stuff. And then the most complex thing we actually did on the network was that in New Zealand, with $1,000 a meg transit, it was much cheaper to buy domestic. So we kind of separated that out, initially onto separate routers, then long-term onto separate VRFs. And we had no NOC, no help desk, just the 5 of us engineers and 1 manager, where if you call up the company, because we had a small number of customers, you'd actually get an engineer who was building the network. And while that was a bit of a hassle at times, you'd be focusing on something, it's actually pretty good because it meant that your customers knew they weren't talking to someone who didn't know what they were doing, but they'd be talking to someone who could just log in and fix it. And we avoided all these complex services like VPLS or Alt3 VPN, just tried to keep it really simple. And often keeping it simple would give you double the services you bought, so that way if one went down, you couldn't complain. So radio was also our friend. So as Jonny mentioned, initially we had only 1 fibre up and down the country. And that was really challenging when we had fibre cuts, right? Because customers generally like their service to work. So we bought a very low capacity radio path up and down the country and some quite expensive shaping cards that let us do hierarchical quals and keep the customers we cared about happy during fibre cuts. And we kind of over time this got harder and harder to manage as the traffic grew. And we started with maybe a little bit more capacity quite a bit more capacity on the radio path available than we were using. And then by the time we actually expanded the network to have multiple paths up and down the country, we probably had a quarter of the capacity we needed available on the radio path, and customers weren't especially happy at that point. We also used radio for accessing our customers. So we had a lot of partners who would do a radio shot from our roof of a bunker to a customer on a farm somewhere. Or customers would sometimes bring their own radios and just install them on our roof, and we'd give them an Ethernet port with power on it. So kind of really did what we had within the constraints, but actually built a pretty cool service for some people. Because at the time, New Zealand didn't really have a whole lot of metro fibre available, so you had to really make do with what you had. And the bigger thing here was learning to debug and reverse engineer. So, look, a lot of people grow up in their careers with a resident engineer or a good tech contact, or they're spending a few $1 million with a vendor, so the vendor will help them. Not so much for us. We had to get pretty good at TCP dumping a BGP session coming up to find that bug, or be able to do iPerfs around the network, or all sorts of different things. So we actually had in every POP a server with 4 1 gigabit NICs, so we could plug in and run an iPerf or do whatever we needed to debug a customer problem. It was pretty handy because if a customer complained, you could drop some iPerf servers into their service and let them iPerf against you and prove out where the problem was. But the biggest challenge there was actually that most customers in New Zealand didn't really understand TCP windowing. So we spent a lot of time teaching our customers how TCP windowing worked and how to actually use this really fast service they'd got at more than 50 megabit. And onto the out-of-band network, one of the biggest challenges was, that most ISPs run into is that you've got kind of an ISP service you might buy for out-of-band, and you've got to jump into a box and then try and log onto a console server. Well, we had 96 fibres, so we built a totally separate out-of-band network on a different core again, so the rats struggled to get to it. And initially this was just like a layer 2 on desktop switches that we bought in an auction, and we kind of put them in the POPs and attached IP phones and cameras and these, these dry contacts to them. And then over time we moved it to a routed network as we got more than just a linear up and down the country. But what was cool is we were in a position where you'd never be making a change on a device over the path that you were changing, right? So you'd be going totally out of band. So if you screwed up, you could roll it back pretty quickly, which was pretty useful given it was a single path up and down the country, and screwing up could mean a pretty big impact for customers. So at the end of the day, making do with what we had, we built redundancy in some pretty unconventional ways, and we made it better as we sold services. So obviously the moment money's coming in the door, you can do a bit more. But we really had to have a detailed understanding of how the network worked to be able to operate it responsibly and to be able to get to a position where customers were happy. We became the primary provider for a whole bunch of really important customers like the National Power Grid, a few power plants, police network, government shared network, and almost every ISP bar the 2 telcos who ended up buying our fibre off us because they wanted our parts. So we fundamentally changed the market, taking the price of a 10 gig wave from multiple hundreds of thousands of dollars a month to around $10,000 a month, and ultimately sold the company with $1 million of network equipment for $116 million in 2014. So as much as this might have been pretty dodgy at the start, we actually achieved a really good outcome for New Zealand, where users could get pretty fast internet after we were done. Any questions?
Alrighty, well,
Cool.
Thank you very much.
Thank you very much. Hello? Oh.
Sorry.
Sorry.
I could take a hint. Patrick from Markley. This is going to sound like a silly question, but it's actually very serious. You dumped essentially concrete bunkers in the middle of army land. I've tried those kind of things in other places, and there was a serious worry about them being blown up. Did you have anything like that?
Yes.
That's true for the fiber path as well. I mean, Army guys and gals like to do things that are not conducive to networking equipment or human beings.
Luckily, this one was about 100 feet from the road and close to the actual town there. So we had a shared fate, you could say.
Yeah.
All right. Thank you. By the way,
No, it was challenging though.
It's my favorite presentation of this NANOG. Thank you.
Oh, thank you.
Thank you.
Anything else?
Anyone else? Cool.
Ready.
Thank you.